In this video, I'll be showing you how to use the LM335 temperature sensor on the NI6009 set. But before we start, we need to locate the NI-DAQ Max palette in the block diagram. To locate the DAQ Max palette, go to your block diagram. Right-click and open the function palette and go down to Measurement I/O palette. And there, you'll find the NI-DAQ Max palette. It is recommended to pin the palette on your block diagram. Look for the pin icon on the top left hand corner and click on it. Firstly, we need to use the Create Virtual Channel function. Click and drop the function on the block diagram. Click the drop box at the bottom of the function and go to Analog Input and select Voltage. Next, right-click the physical channels terminal of the Create Virtual Channel function and create a constant. Click on the constant and select Device 1 AI0. Next, we'll be adding property nodes. Property nodes are used to get or set a property of a specific function. In this case, we would want to set the minimum and maximum voltage input, terminal configuration, and sampling timing type. Add 3 channel property node and 1 timing property node and arrange them as such. Next, right-click on the first channel property node and select Change All to Right. Repeat this step for the second and third channel property nodes. Next, click on the first channel property node. Go to Analog Input and select Minimum Value. For the second channel property node, go to Analog Input and select Maximum Value. For the third channel property node, go to Analog Input, General Properties, Input Configuration, and select Terminal Configuration. For the timing property node, select Sample Timing Type. Next, create a constant on each of the property nodes. Next, we'll be setting the minimum value to 0 and the maximum value to 5. The terminal configuration will be set to RSC, and the sample timing type will be set to On Demand. Next, create a while loop with a stop button. Then, add the wait in millisecond function in the timing palette. Right-click on the left terminal of the wait in millisecond function and create a constant. Type in 100. The wait in millisecond function acts as a delay for every iteration that the while loop executes. Next, add the DAQ Max read function. Click the drop box at the bottom of the function. Go to Analog, Single Channel, Single Sample, and select DBL. The data from the data terminal is in voltage. We need to convert the data from voltage into degrees Celsius. The formula is the input voltage multiplied by 100 then subtract by 273.15 and you will get the data in degrees Celsius. Next, wire the terminals as such. Next, create a thermometer on your front panel. Wire the output of the subtract function to the thermometer. Next, add the DAQ max stop task and DAQ max clear task functions to the block diagram. And wire them as such. If you prefer to have a digital display, you can right-click the thermometer and go to Visible Items and select Digital Display. From here on, you can run the code and read the temperature reading on the front panel. If you are unable to get the temperature sensor to work, check your physical channel constant on the Create Virtual Channel function. Check whether you have selected the right input channel. Another way to check is to see whether you have selected the right setting for the DAQ Max Create Virtual function, as well as the DAQ Max Read function. Another way to check is to open up a software called NIMax. On the left hand side of NIMax, you can see the devices that is connected to your PC under the Devices and Interfaces tab. So once you have identified the USB 6009 that is connected to your PC, run a self-test to check whether